right. So this is our lesson on kites. And I want us to, we're gonna focus on this page right here. I'm gonna flip back and forth, but for you, for your sake, kind of focus on just the big kites page. What we're doing is we're taking all of these words that are on the second page and putting it on our picture, our big picture of the kite, so we can understand all of the properties. So the first thing we need to know is, by definition, what is a kite? A kite is a quadrilateral, so it's a four-sided figure, and it has exactly two pairs of consecutive congruent sides. We've never really talked about consecutive sides. We always talk about opposite sides. We talk about consecutive angles, but we've never really talked about consecutive sides. So that just means that a kite has these two sides that are next to each other that are congruent. So KE is congruent to IK, and then ET is congruent to IT. So I want you to mark your picture up like I have my picture getting marked up. Hopefully yours looks slightly better than mine, but just mark it up. EK and IK are congruent, ET and IT are congruent. Okay, that's the definition. A kite is not a parallelogram and it's not a trapezoid. It's its own special quadrilateral. I've got a little baby kite on the second page for you. The reason that we say that there are two distinct pairs of consecutive congruent sides is because if all four sides were the same length, then it would be a rhombus or a square and not a kite. So it's two distinct pairs, not all four, 2 and 2. All right, now we're gonna read properties of kites. Again, you should be kind of kept on your big kite page, and I'll just keep flipping back and forth. So I'm sorry if I give you a little bit of whiplash. One thing that's important to know about kites is their diagonals are perpendicular. So that means that KT is perpendicular to EI. I've got little right angles right here at M all the way around. So just like rhombuses and squares, my diagonals are congruent here. Okay. The next thing, it says, a longer diagonal bisects the shorter diagonal. Okay, that's a mess. First thing I want to do is let's label, I'm going to label EI as the short diagonal. So I'm going to literally go on here and write short diagonal. And KT bisects it. So I'm going to put little congruent marks here. 1, 2, 3, 1, 2, 3. I can't use just one and I can't use just two because EM is not congruent to EK. So I have to use my own little individual marks. I'll even do this. I'll color coordinate so we can see it on the other page. I'm going to label KT long diagonal because I labeled EI short diagonal. So I want to label this one opposite. I'm going to call it the long diagonal. And those are words we're going to use. I'm going to say, okay, what about the long diagonal, or is it the short diagonal? So we got to kind of make sure we know what's happening there. So that means that it's a perpendicular bisector because they are perpendicular and it bisects that. So those are good things to learn. I'm going to also highlight my little right angles just because that was something new I put on here too from my first step. My third step, my third property says the longer diagonal bisects its opposite angles. The short diagonal does not bisect its opposite angles. Okay, use a little pink guy for that one. My long diagonal KT is an angle bisector. So I'm going to go write that on my long diagonal. I'm going to say angle bisector. Because when I go up to angle K, I'm going to put that those two angles are congruent, and I'm going to go down to angle T and say those two angles are congruent. So angle K has this angle and this angle are congruent. And then down at T, those angles are also going to be congruent. However, they're not congruent to the ones at K, so I'm going to put 2 marks here. I'll still highlight them pink so we know which step we learned this in. Going back to property number 2, I forgot to write this one down, but I'm going to write it down while I'm thinking about it. The long diagonal is an angle bisector, and then I said this, but I didn't write it down. It's the perpendicular bisector of the short diagonal. So I'm going to write of short diagonal. I know it's probably confusing for you to see this all come horizontally on your screen. I like physically have my iPad sideways so I can write kind of legibly on this, but like you might be like looking sideways with your head to see this nicely. So the long diagonal is an angle bisector, and it's the perpendicular bisector of the short diagonal. Okay, we've got 2 more properties. Any questions so far? Before I leave here, I'm going to show you at E and I, these are not angle bisectors. The short diagonal is not an angle bisector. This is not congruent to that. I even showed you a big example that's super exaggerated. There's no way this looks like it's the same as that. So I made sure to give us a kite where it was very clear that this was not an angle bisector. You can even write that on the short diagonal if it makes you happy. You can write not angle bisector. Whatever helps you know what you need to know, that's fine with me. Okay, even though it's not an angle bisector, I have something special about angles E and I. Those angles are the only pair of angles that are congruent to each other. So that's the 4th property. I'm going to use a purple highlighter. Only one pair of opposite angles is congruent. They're the ones joined by the short diagonal. So angles E and I are congruent to each other. I've got to use 3 little marks because I haven't done that one yet. 3. Angles E and I are congruent to each other. They are not congruent to K and T. They're congruent to each other. Any questions so far? The last property is just kind of like a helpful hint. It says, it's helpful to think of the longer diagonal as a line of symmetry of the kite. If you fold the figure on KT, 2 halves will match up. In other words, we've got these triangles that are congruent by side, side, side. This will help us keep track of which opposite angles are congruent, which opposite angles are bisected, etc., etc. So next to long diagonal, underneath that, I'm going to write line of symmetry. I feel like I've brought up this like concept before. Line of symmetry is like when you were in elementary art school and they made you like paint on one half of a picture and then paint on the other half, or like and leave the other side blank, and then you like smushed it together and then it was like a beautiful butterfly. That's the exact same thing here. I don't know if you can see me, but I want you to look at me really quick. I've got my picture because I, benefit enough to have a printout. If I were to fold it down the middle, down that vertical diagonal, the long diagonal, I would sandwich it perfectly on both sides. Let me fold it so you can see both sides. That helps me know that angles E and I are the ones that are congruent because they're the ones kind of back to back right now. It helps me know that K and T are the ones that are being bisected because their parts are right on top of each other now. I know that EM and IM are congruent because they're right on top of each other now. So think about it being like a hot dog fold back in 1st grade along the like long diagonal. Whew, okay, those are all the properties of this shape. Anybody have any questions so far? All right, we're gonna flip back. We're gonna go to the bottom part right here on the 2nd page, and we're gonna do true and false. So I'm gonna need 1 person for each answer, true or false. So the first one says AC is perpendicular to DB. Who wants to answer that one?
I can.
Go ahead.
I'd say that's true.
I think that's true too. I'm gonna say that's true and I'm gonna mark it on here. AC is perpendicular to DB and it's perpendicular all the way around. Very good, Ava. All right, what about the next one? Is DAB congruent to DCB? Is DAB, this angle right here, That whole angle, is that congruent to DCB? Somebody else, what do we think?
It's true.
Why is it true, Maggie?
Because the short diagonal, the two whole ones are congruent.
Good. The short diagonal is the one that has the two angles across from it that are congruent. So big angle A and big angle C are congruent. Very good. Okay, the next one says angle ADC is congruent to angle ABC. ADC. So I'm going to highlight this one yellow. ADC is congruent to ABC. Somebody else knew. What do we think about that? True or false?
I said false.
I think you're right. Why is it false, Silas?
Because they're just two totally different angles. I mean, you can pretty much visibly see it.
Yeah, so Silas is like, I visibly see that they're not the same size. What we know is that the long diagonal does not have congruent angles opposite it. So we get to say false on this one. Very good, Silas. What about the next one? AP is congruent to PC. AP.
Is that true?
That is true. Abby, why do you think that's true?
Because line DB bisects line AC.
I love that. Great vocabulary. We already know she picked the first one we said was true. If it is, or no, not even that one. You said they bisect each other, which is even better. That's one of the properties that we learned above. That is a true statement. All right, somebody else knew. I've got DP is congruent to PB. What do we think about that? Are these lengths congruent? Somebody knew.
Yeah, they're not congruent.
Awesome, Charlie. Why are they not congruent?
I don't. I can just see that they're not. I don't know like the exact rule though.
That's similar to what Silas said. We just physically see that they're not congruent. This is like the same property I was talking about with Silas, is like we know that the opposite angles are not congruent. We also know that the long diagonal is not bisected. If you even look at our original picture, it is very clear that like one part is way smaller than the other part. So just by definition, by property, it's not true. So we're gonna say false. All right, I've got two more. AD is parallel to BC. Is AD parallel to BC? Somebody else I haven't heard from. Okay, I'll find a friend. Van, can you help me? Are those two sides parallel?
A, B, and DC.
A, D, and B, C.
Oh, no.
Why not? I agree.
Because like they're like visibly not.
They're visibly not. Like this drawing sucks. They're visibly not. Have I said parallel once today?
No.
No, not once. This is not a parallelogram. So even if Van could not blatantly see that they weren't parallel, we don't have any lines parallel. So that's not a true statement. And then the last one on this side, it says DB is a perpendicular bisector of AC. DB is a perpendicular bisector of AC.
True.
I agree with that. Why?
Because it makes a right angle.
It makes a right angle, and what else? That's a perpendicular part. What tells me it's a bisector? So DB is a perpendicular bisector of AC. Why do we know that AC is bisected? Remember the one, I think Abby did this one, AP is congruent to PC. we knew that these two segments were congruent. And so since those two segments from the vertex to the midpoint and then from the vertex to the midpoint are congruent, that means it's bisected. So exactly right. Max, you're right, but that's why. It's 90 degrees and we've got to write a midpoint in there. Cool. All right, let's jump over. Let's look at letter E. This one says given kite. We've got EKI is 80. We've got KET is 110. Let's label that. EKI means this whole big angle right here. Let me find a more striking color. This whole angle is 80 degrees. And then KET, this whole angle is 110. All right, slate is cleared. Anybody I've already talked to can talk to me again, but we got to answer these questions. First one says KIT. Who knows what KIT is?
Is it 110?
Why is it 110, Ava?
Because I forget which property it was. Only one pair of opposite angles is congruent, and the ones that are joined by the short diagonal.
Mm-hmm. Good. So Ava remembers the only pair of angles that can be congruent are the ones joined by the short diagonal. So that means that KIT is 110. Very good. What about ETI? ETI. This angle down here, what do we think? What kind of shape is this, guys? Besides a kite, what? I asked that.
Triangles.
Say kite. There's a ton of triangles, but what's this big general shape? Maggie, did you know when I interrupted you?
Is it an isosceles triangle?
We do have a big isosceles triangle down there at the bottom, but what is this whole shape? How many sides is this shape?
4.
Is it a parallelogram?
It's
Is
not.
it a rhombus?
It's not a rhombus. It's just a basic quadrilateral. How do I find that missing angle at T if it's a quadrilateral? Anybody know?
Add them all up and minus 360.
Awesome, Sydney. We have to add up all of them and minus them from 360. So I've got 110, 110, 80, and then we don't know what T is. So we're gonna add up all 4 of these. Oop, missed the one. And set them equal to 360. If I add these, I think I get 300. And then if I minus that, I get 60. So we got to remember not even just the new stuff we learned, but the old stuff we learned a long time ago. Good work, Sydney. That's my ETI. All right, next I've got to do EKM. Thoughts on EKM?
40.
Why is it 40, Charlie?
Because KT bisects that angle into 2 halves.
Very good. KT bisects that angle into 2 halves. So Charlie knows that that half is 40, and we're going to write that this half is 42, just in case we need to remember that later on. So 40 and 40. Very good, Charlie. Next, I want to do KEM. Before I do that, what do we remember about the diagonals? What do we know about the diagonals of a kite?
They're perpendicular.
Very good, perpendicular. So I'm gonna go in here and write perpendicular in all of them. What might help us? KEM.
It's a right triangle. So you would add 90, 40, and then so like x plus 90 plus 40 equals 180, and then you subtract that from 180 to get, I think it's 50.
I think you're right. Ooh, I did not do that right. X equals 50. So what we did is I asked what we remembered about the diagonal. So Sydney reminded me that they were perpendicular. So then that helped Ava see that we've got a right angle, a little right triangle. So 40 and 50 and 90 add up to 180. So that's KEM is 50. I'm gonna also argue that across from it is also 50. I could do literally the exact same thing. I still have 40, I still have 90, and I'm gonna have 50. So I'm just giving us a little hint that that's there. Now I need to do MTI. MTI.
Would it be 30?
30, why?
KT is an angle bisector of T, and we already figured out that T equals 60.
We already figured out that T was 60, and so we've got this whole angle is 60, and to split it evenly is 30 and 30. Good, Sid. 30 and 30 MTI. The only angles that we have left are MET or MIT, whichever one you want to find. MET is the one that we ask for. What are we thinking for that? Got some people I haven't heard from. What are we thinking, guys?
50.
Where'd you get 50?
Or 60.
Oh, where'd you get 60 from, Silas?
Wait. No, I think it would be 60 because it's sorry, I'm trying to phrase it right.
I think
you do
right.
60 plus 3. Like I know how to do it. It doesn't really follow the stuff that we've been doing, because like
okay.
On the other side of like KEM,
yeah,
I'm from like that angle. If you do the other side of it, then it's going to be 60, and then plus the bottom is 30, and plus the next one is 90, and all triangles equal 180.
Good. You gave me a lot right there. You didn't even have to give me that much. The one thing that I want to dig in on is Silas first didn't even use a triangle. He used that these angles add up to 110. And so if he knew the top was 50, then 110 minus 50 is 60. Right, Silas?
Yeah.
So he just did simple angle addition. We could have done right triangles like we did above. We could have looked at this triangle right here, 30, 60, 90, and figured out that it was 60 easily. But even more simply, Silas just did an angle addition, and it was very, it's exactly what you needed to do. 60 is the only thing that's left that adds up to 50 to get 110. So perfect. Okay, now I want to stress these congruent triangles. So I have KIM is congruent to what? Let me erase what I already have highlighted. I'm going to highlight KIM. There's 3 sets of congruent little triangles in here in this big kite, and I want us to identify them. So KMI is right here. Somebody give me the triangle it's congruent to.
KME.
KME. The one right next to it, KME. These 2 red ones are congruent. Okay. What about TME? Somebody else, what is this one congruent to?
TMI.
TMI. It's funny when the triangles are named funny.
Did you do that on purpose?
I did not. We just use kite and then we use M for midpoint. But sometimes on tests I do. I try to name them funny, but this time I didn't. And then the last one is EKT. I'm going to erase all that because EKT is going to be EKT right here. And then somebody else give me what triangle EKT is congruent to.
Would it be IKT?
IKT, awesome. Good job, Gavin. IKT. I love how carefully Sydney and Ava and Gavin all named their triangles to make sure that it matched, the angles were congruent to each other. Okay. what we are going to do is I'm going to respect your lunchtime. I am going to keep the recording going, and I'm going to do 9, 10, etc. for the other class. I suggest you guys come back to watch the YouTube video to look at these last few problems, but I will not hold you guys, so you are free to go to lunch. If you need anything, let me know. And again, this is not due until after the quiz. So if you're feeling really bold, do it tonight, but I would rather you spend your homework time tonight reviewing. Okay? Any questions before you go? If not, have a good lunch.
Thank you.
Thank you.
This is William.
Yeah, Gavin.
So I was gone like Friday through Sunday. So it's okay if I just turn in the homework that was due today a little later for.
Turn it in. Do it before the quiz. Let's turn it in by Wednesday.
Yeah, I was just gonna do it like tonight.
Perfect. That works for me, Gavin.
Bye.
Thank you. All right. So for those of you on YouTube, you could have skipped that last minute, but I am going to do 2 more examples very quickly before I let you guys go. So this example says in kite ABCD, and then it labels it. So let me draw a kite. Okay, that's as good as Notability doesn't want to really give me a kite, so I'll just draw one a little bit better freehand. So those 2 are congruent. That's as good as a kite as we're gonna get, ladies and gents. You can make fun of me when I see you in person next, okay? AB is congruent to AD, so we'll put A up here and we'll put B and D here because these guys are congruent, and then BC is congruent to DC. Now it's important to draw a picture regardless of how silly it looks, because I need to know what can be marked congruent and what doesn't, because if I just look at these pieces, I'm not going to know individually. But I know that AB and AD are congruent, so I'm going to set those 2 equal to each other. 3x minus 4 is equal to 2y plus 5. Oh shoot, that's disappointing because I can't solve that right now. But I also know that BC is congruent to DC, so BC is 8x or 8 plus x, and CD is y plus 7. This is one of our classic substitutions. So you can solve for anything. I usually like to solve for y. I don't know if that's something I was taught a while ago, but I'm going to solve for y. And I'm going to get x plus 1 equals y. Okay. That gets to get plugged in for my y over here. I'm going to replace y with x plus 1. Again, I set up my equations, and then I solved for one of the variables in one of them, and now I'm substituting it in. So now I have one equation with just one variable. I can solve that. So 3x minus 4 equals 2 times x plus 1. So weird, plus 5. Distribute, combine like terms, all that fun stuff. So I'm going to do 3x minus 4 equals 2x plus 2 plus 5. I'm going to combine those guys. I get 3x minus 4 equals 2x plus 7. And then now I'm going to get my x's together minus my 2x, and then I'm going to add my 4. So x equals 11. Now, once you find x, I'm just going to substitute that into my first equation. 11 plus 1 equals y. That's 12 equals y. And then it asks me to find the perimeter. So that's just the preliminary part. So on the ones with x, I'm going to plug in 11. On the ones with y, I'm going to plug in 12. So I'm going to do BC first because that's easiest. 11 plus 8 is 19. And so DC should also be that. 12 plus 7 is also 19. Cool. And then AB is 3x minus 4. So 3 times 11 minus 4. That's 33 minus 4, which is 29. DA is 2y plus 5. So 2 times 12 plus 5 is 24 plus 5, which is also 29. Perfect. And then perimeter means I just add them all together. So I'm going to do 2 times 19 plus 2 times 29. You can write this a variety of ways. But 2 times 19, oh, it looks like I didn't do that on my key. 2 times 19 is 38, and then 2 times 29 is 58, and then when we add them together, I get 96. Okay, I'll pause it. If you need to look at that, I'd pause your screen and take a look at it. All right, last problem I'm gonna do is this one says given kite, K-I-T-E, K-I-T is 60, K-I-T, this whole thing down here is 60. And then EKX is 55, EKX, angle 4 is 55, and then find everything else. Number 10 says find all numbered angled measures. This is a lot like the one we did above. So I almost would like pause me and decide like what's congruent, what's bisected, whatever, and then solve those. So I'm going to start with the easiest part, I think, which is the bisected one. So that this is 60, angle 6 is 30, and angle 7 is 30. I know all of these are 90 in here. So I did my little 90 box. If angle 6 and 7 are 30, then that means 5 and 8 are complements to that. So that means that they're 60. Angle 9 and 4 are congruent. So that's 55. And then we could add like this and that and this and find 1 and 2. But I think an easier way personally is if I just think of this as a little right triangle. So I've got 55 plus 90 plus X equals 180. And that's going to give me angles 1 and 2. And I believe that's going to be 35. So angles 1 and 2 are 35. Again, I know I did that pretty quickly, so pause or rewind and watch this little part. These are all properties of your kite. Use your front sheet to know what's congruent, what's angle bisected, what's not, etc. So I did that. I found all the numbered angles. Check. Name 3 pairs of congruent segments. Okay, I know that those 2 are congruent, so EK and ET. And I also know that KI and TI are congruent. That's the basic definition of a kite. KI and TI. The one property that I'm going to use now is that the long diagonal bisects the short one. So the last set of congruent segments I know is KX is congruent to TX. KX is congruent to TX. Okay. So I know all of those things. The next one says name 3 pairs of congruent triangles. Again, very similar to what we just did up here. So maybe pause and see if you can replicate what we did up here down on this new triangle. I'm going to start smallest to biggest. So I think the smallest triangles I can do are EKX is congruent to angle ETX. So I'm looking at these 2 up here. Next, I'm going to do the second biggest, like the medium-sized triangles, these guys and these guys, which is KXI and TXI. KXI, TXI. And then last is the top half and the bottom half. So ETI, so that big triangle, and then EKI. ETI, EKI. We went a little bit slower on that above, so if you need a reminder, rewind back above. The last 2 are true and false. True or false? If a quadrilateral has perpendicular diagonals, then it's a kite. Is that the only quadrilateral we know with perpendicular diagonals? No, right? The other day we literally learned about rhombuses and squares also have perpendicular diagonals. So just because if I know it's a four-sided figure with perpendicular diagonals, it could be a rhombus or it could be a square. And then true or false, diagonals of a kite bisect each other. I'm going to say false on this one too. They don't bisect each other. The long one bisects the short one. I'm going to say long bisects short. But the long one's not bisected, so that's not a true statement. All right, that is it. We are done. Feel free to rewatch any of this. The biggest thing I want you to remember is this step that we learned at the very beginning, all the properties of a kite. Remember, this is not on the most recent quiz. It will not be on there, but you are responsible for it for the next time I see you, and it will definitely be on the test. So if you have any questions or concerns, let me know. If not, have a good rest of your day. I'll see you guys soon.